Today we're going to look at parametric equations from physics. Now we have a couple of equations right here that we're going to be using. I'm just going to give you these. For example, to find out the horizontal distance an object will travel in physics, when we throw something, we use the equation v naught cosine t, where v naught is the initial velocity. To get the vertical distance, the height of it, vertical, we use h naught v plus with initial height plus the initial velocity sine of theta t minus 16t squared. This one probably looks a little more familiar to you from physics than the first one. Now the first question says we want to find the maximum height of a ball. And to do this, we are going to write some equations down here. And if I want to find the horizontal position of the ball, we're going to use x equals v naught 88 cosine of 60 t, and I get the y value, or the vertical component of it. We get 88, because h not 0, we'll assume, plus 88 sine of 60 t minus 16 t squared. And we can sketch this. We'll talk about that later on, how we can sketch that, but we want to answer some questions first. Question 1. It says, find the maximum height and distance the ball will travel. So in order to get this, we're going to graph it. Now, if I want to find the maximum height the ball will travel, let's take a look at, we have to look at the y variable here. Okay, so we're going to graph this on our calculator. So on the calculator, if we sketch this, we can go y equals, clear it up first, 88 sine 60 t minus 16 t squared. And of course we're using x's. And I want to graph this. And there it is. Now, I noticed something right away kind of strange. My x is negative. I don't expect that, so I'm probably in the wrong mode. Yes I am. Change to degree mode. Make sure you're in the right mode. And now when I graph it, at least my graph will now, take a look, here it is, and it's coming, there it is. I'm in the first quadrant, which is where I want. Now I can't see the height, so I'm going to change my window a little bit. Obviously, that don't need too big of a negative, but my x max, I don't need to go out there, maybe go out to 6. My y min, maybe make that 0. My y max, I want to find it, so I'm going to make that, let's say, 50, and see what happens here. There's my graph, and let's see here. That's good, but I'm still going to make my y max a little bit bigger. Maybe make it 70 so I can at least see it. Play around a little bit if you need to. It's still not there. Alright, so let's go crazy here. Let's go make that 100 this time, see what that does. And, perfect. Now I can actually see the max. And there's the path of our ball. Now, I want to find the maximum height. Well, how can I find that on the calculator? Well, to get the max height, we've done this before. Go second, calculate maximum. Minimum value, I know it's between 0 and my right bound, 6. Hit enter, just take a guess. And it gives me a maximum height at t equals 2.382 seconds, and the height is 90.75 feet. So there's my maximum height. Now, I also want to get the maximum distance. Now, that's a little bit different because that doesn't necessarily involve my y-coordinate. That involves x. So what I'm going to do to get the maximum distance, since I'm starting and ending at the same height, I can really just double my time. So to get the maximum distance, the time is going to be 2 times this 2.382. And now I'm just going to plug that into my x-coordinate because this is dealing with the horizontal. So I go x equals 88 cosine of 60 degrees times 2.382 times 2. Oh, got to multiply that by 2. So let's multiply that by 2 here real quick. 2 times 2.382, go to 2 point, weird, 2 times, there we go. And that's going to give me 4.764. And I'm just going to go type this in my calculator. 88 cosine 60 times 4.764. And that's going to give me 209.616 feet. And we can answer those. So practice this again if you think you need to, okay? It's kind of fun to do. All right, now let's talk about some real-world problems. A baseball. A baseball leaves a bat with an initial velocity of 152 feet per second. They gave us V naught at an angle of elevation 20 degrees, theta. The ball is 3 feet above the ground. That's easy. That's our H naught when the ball is hit. A 20-foot fence lies 400 feet away from home plate. We'll talk about that later on. Write a parametric equation to model the ball. Now, we're going to write a parametric equation, and then we're going to graph this, okay? It's kind of fun to do. So to write our parametric, to get the horizontal component, it is going to be V naught, which is, what was it again? 152 cosine of the angle, 20 degrees, times t. To get the vertical, y equals H naught, which is 3, plus the V naught, 152 sine of 20 degrees t minus 16 t squared. Now, very easy to do. Okay, so those are my parametric. Now to graph these in parametric mode, here's what we do. We have to change our mode. Now we're already in degrees, we just make sure we're in parametric mode. Go PAR for parametric. Go to y equals now, and if you notice, you get your two equations, x and y. I just type them in. 152 cosine 20 t, enter, 3 plus 152 sine of 20 t minus 16 t squared. And now what will happen now? I'm going to change my window quite a bit. I'm going pretty far. Now notice my T-min and T-max. That's just to count how many seconds will the ball be in the air. Let's go 8 seconds. 0 to 8 seconds. That's okay. We'll talk about that later. It doesn't really matter much for the graph. My X-min. Now I'm probably going to go slightly further than 6 feet away. We're talking about a fence 400 feet. So let's make that maybe 500. Y-min, 0. It's okay. Minimum height. My Y-max, a ball traveling 100 feet up in the air. Could be. Let's graph this. That's actually the path of the ball. So when you hit the ball, that's actually the path the ball makes. And there's Mr. Warren not making the catch. Crowd goes wild. So when I graph this, here we go. Here's 3 feet. That's where it's starting. And there's the path of the ball. There's my sketch. Now, the next question says, okay, 400 feet away. So at 400 feet away, there is a fence that is 20 feet tall. We want to know is, will the ball clear the fence? In other words, will they make a home run? Suspense, I know, is killing you. Well, let's find out. All right, so to see if it clears the fence, here's what we're going to do. Go back to y equals. You can have basically y equals. And you're going to have, go down to x2, y2. Now, the fence is 400 feet away. So at x2, I'm going to put 400. The height of the fence, y2, is 20 feet. So I type in 20. And now I graph it again. Now, it doesn't look like much, but if you notice, take a look here, a little dot shows up. And that dot is right below. There's that dot right here. It shows up at 400 up 20. That's basically what it does. At 400 up 20. Take a look. Now, the ball, is the path of the ball above that dot or below? So it's above. So we could say this. The ball will clear the fence. The ball clears the fence. And that is because the path of the ball is greater than the height of the fence, F1, than the height of the fence at 400 feet. And the dot shows us that. All right, so go to part 2. We'll take a look at a couple more examples.